Mathematics made easy, no more fear. Target online class, we got you. Wherever you want it from, we got what you need. Target online class.
Good day, viewers all over the world. You are welcome to Toydale online class. Today we want to talk about integration by path. Integration by path. Of course, we have introduced integration and we have discussed some concepts about integration. So we want to look at integration by path. In case of integration by path, if you have integral u dv, is given as uv minus integral v du. This is how to express an integral problem under integration by path. If you have integration by integral v du, it should be v du, v du. It will be given as u dv. That's what you have under integration by path. That is, whatever question that you are given, you break it down to v, then integral du. So once you are able to do that, then if you're able to do that, then you are going to have this expression. So under integration by path, you have integral v du to be equal to uv integral u dv. So for instance, let's take example. For instance, let's say example, if you are to evaluate or integrate, want to integrate a, let's think about 3 questions. A, where you have integral x e minus x dx. Then B, where you have integral s squared sine x dx. Then C, where we have integral 2x in x dx. You realize that under integration by parts, you have the product of 2 different functions. For instance, in this first one, this is a polynomial function and exponential function. Here, polynomial function and trigonometric function. Then this is polynomial function and logarithmic functions. So under integration, whenever you have question, where you have product of 2 functions, integral of product of 2 functions, most often time we applied what is called integration by part, because in this case, now even if you start to differentiate or integrate, you might not be able to solve that type of problem. Then how do we apply integration by part? I will start with the first example. I'm going to start with the first example. The first one, A, where we have integral x e minus x dx. So this is the formula for integration by part. Integral v du is equal to uv minus integral u dv. So what we have here, you break it down to v. That is to say, you can say let let v to represent x. Then once we call v x, if v is x, then integral du will be the remaining thing. That will be e minus x dx. That's what you have. That is, this is what we have done now. Look at, compare these two. What is the formula? Integral v du. So call the first one. It depends on v is equal to x. If v represents x, then integral du is going to represent integral e dx. Then I can go ahead and find the v. The v will be equal to dx. Okay? Because the v dx is 1. When you cross multiply, the v is equal to dx. Then here, if you integrate du, you are going to get u. Will be what? If you now integrate exponential e minus x, this is just minus 1. You're going to have minus e minus x. That's what you are going to have when you do that. So if you integrate that, that's what you are going to get. We now go ahead and we now go to the formula, which is integral v du is equal to uv minus integral u dv. So here now integral x e minus x dx will now be equal to, what is u? U is given as this. U is minus e minus x multiplied by v. V is equal to x multiplied by x minus integral. What is u? U is minus e minus x multiplied by dv. Dv is dx. Dv dx. That's what we are going to have. Just substitute the value back to what we are given, like as we have done it on the board. Then from there, we are going to have it to be minus xe minus x. That's what we are going to have. Then here, minus times minus is plus. So we are going to have plus integral e minus x dx. Then from here, I'm going to have minus xe minus x plus, when you integrate exponential e minus x, the coefficient is -1. Use it to divide. That is t minus 1. Now this will only change to minus e minus x plus arbitrary constant. And that is what you are going to get. That is what you are going to get. Of course, I can bring out minus e minus x outside the bracket, so that at the end of it, I have x plus 1 plus arbitrary constant. And that will be the final answer. So under integration by part, just express what you are given in form of v du. Once you express it in form of v du, check out what you are given, then just fill in the gap. You're going to get the right answer. So that is that about the first question. Then we go to the second one, b, where we have integral x squared sine x dx. So that's the second question. We do the same thing here. I'm going to do the same thing. So what do we do here? We express it. We are going to express it in form of v and du. So we can say v. We can let v to represent. We can say v to be equal to x squared, so that the v dx will be equal to 2x. Of course, the v will now be equal to 2x dx. That's what we have. So if we represent v as this, then that simply means that integral du will be equal to integral sine x dx. Because this is in the formula, we have integral v du. So we have represented v as x squared. Integral du will be integral sine x dx. And if you differentiate that, if you integrate this, u is going to give us minus cos x. That is what integral du is. Then if you have gotten that, then we now come back to say integral x squared sine dx is going to give us integral v du is uv minus integral v integral u dv. That's what you get. So now what is u? U is minus cos x multiplied by, then what is v? V is x squared minus integral, we have u is minus cos x multiplied by, what do we have there? Dv is 2x dx. Then if you look at this critically, we are going to have minus x squared cos x. That's what you get. Minus times minus is plus integral 2x cos x dx. Now look at if you check this, if you check what you have here, it's still the product of 2x and cos x. So we still have the product of 2x and cos x. So we go ahead again to apply the formula for us to be able to express this. Look at this, what I'm saying. This is still the product of 2x and cos x dx. So I'll go ahead again. I'm going to apply this to be able to express this. That is, I'm going to have minus x squared cos x plus into bracket. Look at, let me call this first one v. Here, let me do it somewhere here. I'll say v, let v to be equal to 2x, so that the v dx will be equal to 2. Then the v is equal to dx, 2 dx. Okay, so if v is equal to this, then the remaining one will be du. So that integral du is going to give me integral cos x dx. If I integrate cos, I get minus sign. If I integrate sine, it's minus cos. But if I integrate cos, it's sine. So that u will be equal to sine x. That's what I'm going to have. So instead of this now, I'm going to express this now. I will express what I have here, since it's the product of 2x and cos x, in form of, I will express it in form of, I will express this using this formula. That is, instead of integral everything I'm going to have it as uv. What is u there? U there is sine x. I'm going to have sine x multiplied by v is 2x minus integral u is sine x. Then what is v? Sine x dv rather. Dv is 2 dx. So that is the way to express it. Then here I'm going to have minus x squared cos x plus, I can just do what I have here. I will have plus 2x sine x. Okay, then minus, what is minus 2 can come out. 2 can come out, integral sine x dx. If I integrate sine, I'm going to get minus cos, and that's what I'm going to get. So I'll come back here. From there, from what we have there, I will rewrite everything here as minus x squared cos x plus 2x sine x. Then if I integrate sine x is minus cos, minus 2 into bracket minus cos x plus arbitrary constant. Then at the end of the day, I'm going to have minus x squared cos x plus 2x sine x minus minus plus 2 cos x plus arbitrary constant. That is what we are going to have. And then, of course, from there, we can just we can decide to rewrite what we have on the board, or just leave it like that. Because 2 is common. We can leave our answer like this as the final answer, or do they have anything in common? The only thing they have in common is minus x squared cos x plus 2. 2 is common. This is the only thing that's common. 2 into bracket x sine x plus cos x, then plus arbitrary constant. And that's the final answer that we are going to get here. That's the final answer that we are going to get. So under integration by parts, if you integrate the first time and they still have something in common, you go ahead and apply integration by parts, just like this second example. We've done the first integration. We realize that the result we got here, we see a product of 2x and cos x. We will go ahead and use that again. But if it continues in that order, then we truncate. That is the idea about integration by parts. And then we do the second one, we still have something, the product keep repeating itself, then we are going to truncate. So we are going to see that in our next class. That is discussion for another class. So we go ahead and take the third example under integration by parts, C. Then the third example is when we have integral 2x in x dx. In x dx. So we now split this into 2. Of course, I can say let v to represent in x and du to be equal to integral 2x dx. Okay? No, we break it down into 2. We break it down into 2. So v to represent in x, then du to be equal to 2x dx. So in this case now, when I differentiate the v, what is the v dx here? The v dx will be 1 over x. When we have in x, when we differentiate this, what we get? Then if you cross the v dx will be 1 over. So that at the end of the day, the v will be equal to dx all over x, or 1 over x dx. Here, if I integrate du, I'm going to get u. If I integrate here, if I integrate 2x here, I'm going to have 2x squared all over 2. This will cancel this. At the end of the day, u will be equal to 2x. That's what I'm going to get. Then I'll go back and substitute these values into what we are given. Into what we are given. No, this is s squared. This is s squared. 2 will cancel 2. Then at the end of the day, I'm going to have s squared here. So what is the formula? Integral v du is equal to u minus uv minus integral v du. U dv. That is the formula. When we express it, integral v du is equal to uv minus integral u dv. So let's now express this as instead of when we have integral 2x in x dx, it's going to give you u. What is u here? U is x squared. We have s squared multiplied by then v is in x minus integral u. U is s squared multiplied by the v. The v is the x all over x. That's what you get. S will take care of one of this. Then here we have s squared in x minus integral x dx. So here we are going to have s squared in x minus, if I integrate this, I'm going to have s squared all over 2 plus arbitrary constant. And that is what I'm going to get. Okay, that's what I'm going to get, which will be our final answer. Of course, we can just move a step further and say bring out s2 to have in x minus 1 over 2 plus arbitrary constant. And that is what we are going to have. So I would love to stop here because of our time. In our next video, we consider integration by partial fraction. But please note, under integration by part, the requirement must be met. That is, we express whatever we are given, integral v du, called one of the function v, the other one integral du. You express it as uv minus integral u dv. If you're able to do that, we are not going to have any problem to be able to express that problem, the given question. Thank you, and God bless you all.
Mathematics made easy, no more fear. Target all